When the USS Zumwalt was first laid down, it wasn't meant to fight the kind of wars the US Navy now finds itself preparing for. It wasn't designed to defend carrier strike groups, dominate open ocean battles, or intercept waves of anti-ship missiles in the Pacific. In fact, the Zumwalt class was built for a world that, by the time the first ship launched, no longer existed. In the late 1990s, American naval strategy was shaped by a deep belief in uncontested naval hegemony, the expectation that the US Navy would rule the waves without any meaningful opposition. With the Cold War ended and the Soviet Navy in shambles, the likelihood of another major peer naval conflict seemed remote. Instead, future conflicts were envisioned primarily as regional interventions against smaller states or non-state actors threatening global stability. The Navy anticipated missions such as coastal strikes in the Middle East, precision fire support for Marines deployed in Africa or Asia, and targeted actions against regional actors who might disrupt vital economic interest or global trade routes. In this geopolitical and naval environment, ships like the Zumwalt were designed primarily for land attack and naval gunfire support, providing precision bombardments in littoral zones. They were not intended to operate as part of carrier strike groups or to engage in high-intensity naval combat. The assumption was that these conflicts would be limited in scale, fought with overwhelming American technological and firepower superiority, and focused on rapid and decisive outcomes. In this context, the Navy was preparing not for large-scale fleet battles, but for precise limited engagements similar to the 1991 Gulf War. The Navy was essentially tailoring itself to provide robust support to land forces in order to stay relevant and effective in a strategic environment where no peer naval adversaries existed to challenge US control of the seas. At this time, China was still focused on economic growth, not naval modernization. Russia was struggling with economic and political instability. That doctrine, built on the assumption of US naval hegemony, shaped the Zumwalt DNA. Its radical hull form and low radar profile weren't meant to help it survive missile drills in the Philippine Sea. They were meant to get it close to hostile shores without being seen. Its advanced gun systems weren't designed for sea battles. They were engineered to rain GPS-guided shells onto inland targets from over 150 kilometers away. The Zumwalt was in essence a stealthy land attack platform wrapped in the hull of a destroyer. The ship's crew of just 147 sailors, compared to over 300 on a traditional destroyer, was made possible by extensive automation. This reduction wasn't simply about cutting personnel cost. It was intended to reduce the logistical burden of supporting a large crew and to mitigate the risk to American lives from operating so close to hostile coastline. Automated systems handle many tasks that previously required human operators, from engine control to maintenance to damage control, enabling the Zumwalt to sustain longer deployments with fewer personnel on board. The streamlined manning also allows for a smaller living and support infrastructure on the ship, making it more space and resource efficient in challenging operational environments. One of the Zumwalt's most striking features is its distinctive wave-piercing tumble-home hull, a radical departure from the flared hull form of modern warships. In a tumble-home design, the hull narrows as it rises above the waterline, rather than flaring outward, giving the ship a sharp angular profile and reducing radar cross-section from many angles. This form, paired with the ship's enclosed superstructure, significantly enhances stealth by reflecting radar waves away from the enemy's sensors. The hull is also designed to pierce through waves rather than ride over them, reducing slamming and improving motion in certain sea states. But this unconventional shape comes with trade-offs. Stability in high seas has long been a concern for tumble-home hulls, especially when taking waves at the beam, where the narrow upper section can compromise reserve buoyancy and recovery. Historically, tumble-home hulls were common on late 19th and early 20th century pre-dreadnought warships, particularly in the French and Russian navies. Those ships often suffered from poor seakeeping and vulnerability to flooding when damaged, lessons that contributed to the near-total abandonment of tumble-home designs for over a century. The Zumwalt resurrected the concept, not for gunnery or armor purposes like its ancestors, but for stealth and signature reduction in an age of networked sensor warfare. While tests and sea trials have shown the ship to be surprisingly stable under most conditions, doubts remain over how it would perform in a missile-saturated open ocean fight, especially as the Navy shift away from littoral missions and towards blue water operations in the Pacific and the Atlantic. At around 16,000 tons full load displacement, the Zumwalt is by far the largest surface combatant in the US Navy, larger than any other destroyer or cruiser currently in American service, and also bigger than most surface combatants in navies worldwide. To put this in perspective, it's nearly twice the size of the workhorse Arleigh Burke-class destroyers that make up the backbone of the US Navy fleet. It's even larger than the Type 055 destroyers of the Chinese Navy, whose size have led the US Navy to classify it as a cruiser. Zumwalt's size offers greater range, endurance, and capacity for future upgrades, particularly given its integrated power system that can generate 78 megawatts of electrical power. Beyond hull design, certain compromises made during the Zumwalt's construction revealed how much the Zumwalt was tailored for a very specific mission set, and how that mission no longer aligned with emerging naval and geopolitical realities. The Zumwalt sensor suite, a critical part of any modern warship, was ultimately gutted. The original plan called for a cutting-edge dual-band radar system, the Spy-3 X-band radar for high-resolution surface search, targets tracking, and missile guidance, and the Spy-4 S-band volume search radar for long-range aerial surveillance and early warning. However, in an effort to cut cost, the Navy removed both the Spy-4 and the planned AN/SPG-62 fire control radars, which provide terminal guidance for the ship's evolved Sea Sparrow missiles, the Zumwalt's primary medium-range air defense weapon. As a result, the Spy-3 radar must now perform volume search, surface search, targets tracking, and terminal guidance for the evolved Sea Sparrow missiles, a demanding workload far beyond what it was originally designed for. This consolidation of a huge range of different functions into a single radar places the ship at a disadvantage in managing layered air defense against complex, large-scale missile attacks. In today's fleet warfare doctrine, where ships must detect and respond to massed missile attacks, preferably as early as possible, and ideally from hundreds of miles away, that's a serious limitation. But at the time, it didn't seem like a fatal flaw, because the Zumwalt was never expected to fight that kind of war. The ship's intended operating environment was littoral zones against low-tech adversaries, not blue water engagements with China or Russia. In the minds of the Zumwalt's designers, the ship's radar didn't need to defend against swarms of anti-ship missiles for an entire naval fleet, such as a carrier strike group. The Zumwalt simply needed to defend itself against missile threats of a relatively low intensity. In that context, the compromise seemed acceptable until the strategic landscape shifted. As the global naval balance of power evolved, so did the US Navy's priorities. The rise of China as a major maritime power, the proliferation of anti-ship ballistic missiles, and the emergence of anti-access area denial environments forced a complete reassessment of fleet composition and needs. By the late 2010s, China's shipbuilding industry was in overdrive, and Beijing began investing heavily in naval modernization and expansion. The People's Liberation Army Navy evolved from a green water navy into a blue water navy equipped with modern cutting-edge destroyers, attack submarines, and finally, aircraft carriers. To meet the sudden naval competition from China, the US Navy needed more ships that could operate in blue water environments, defend aircraft carriers and other friendly ships, and strike from a distance. Not vessels designed for littoral environments and for creeping along hostile coastlines. By the time the Zumwalt was ready to deploy, the Navy no longer needed what it was designed to do. This mismatch led many to label the Zumwalt a failure. Critics pointed to its cost overruns, to the cancellation of its precision shells, to the reduction of the class from 32 ships to just 3. And yet, the Zumwalt story isn't over, because the very traits that made it seem obsolete might now make it essential. In a strange twist of strategic irony, the Zumwalt is being reborn, not as a gun-based strike ship, but as a launch platform for a type of naval weapon that America is pursuing: hypersonic missiles. The Navy has begun converting Zumwalt-class destroyers to carry the intermediate-range conventional prompt strike missile system, a weapon designed to hit strategic targets thousands of kilometers away at hypersonic speeds. This transformation represents the most significant change to the class since its inception, and may finally offer the Zumwalt the operational relevance it's long lacked. Hypersonic weapons represent a key advancement in missile technology. Hypersonic weapons travel at speeds exceeding Mach 5, about 38,000 miles per hour, and increasingly can maneuver during flight, especially at higher altitudes. A target 1,000 miles away could be struck in around 15 minutes, compared to the hour or more required for a subsonic cruise missile. The speed, combined with a certain degree of maneuverability, makes them extremely difficult to intercept. The upgrade begins with the removal of one of the ship's two 155mm advanced gun systems, a weapon whose specialized ammunition, the long-range land attack projectile, was cancelled due to an exorbitant unit cost of up to $1 million per round. The removal process is no simple task. Each turret weighs approximately 100 tons and extends deep into the ship's hull. In early 2024, the forward Advanced Gun Systems turret and its deep below-deck mechanisms were removed from the Zumwalt, clearing the space for an entirely new strike capability. By the end of that year, 4 massive launch tubes, each 87 inches in diameter, were installed in the vacated bow section. These tubes form the core of the intermediate-range conventional prompt strike missile launch array, each holding up to 3 hypersonic missiles, for a total loadout of up to 12 missiles per ship. The intermediate-range conventional prompt strike missile itself is a joint Navy-Army development, derived from the Army's long-range hypersonic weapon project, also known as the Dark Eagle. It features a solid fuel booster and an unpowered boost glide vehicle, capable of flying at hypersonic speeds while maneuvering to evade defenses and strike high-value, time-sensitive targets. These weapons dramatically expand the Zumwalt's reach, both geographically and strategically, enabling the ship to conduct prompt, non-nuclear strikes from standoff distances, well beyond those of conventional cruise missiles like the Tomahawk. The scale and the complexity of the conversion efforts are substantial. Following the removal of the advanced gun systems, workers at the Huntington Ingalls Industries Shipyard in Pascagoula installed new bulkheads, structural reinforcements, and the foundations needed to support the massive launches. The launch tubes themselves were delivered in mid-2024 and installed by October. By December, the Zumwalt was back in the water, with live firing testing of the new missile system expected by late 2025. Operational capability is currently projected for some time in 2026. Importantly, the intermediate-range conventional prompt strike missile launch tubes could offer future versatility beyond hypersonics. Rendering and briefings suggest the Navy is exploring other high-payload configurations, such as a 7-cell Tomahawk canister similar to those used on Ohio-class guided missile submarines, and the future Block 5 Virginia-class attack submarines. There is also speculation that the launch cells might eventually accommodate unmanned systems, decoys, or even new missile designs as they mature. This modularity reinforces the value of the Zumwalt's displacement and power generation capacity, giving the ship long-term adaptability in a fast-changing strategic environment. The second advanced gun system mounting on the Zumwalt remains in place for now, but its future is uncertain. Given the cancellation of the long-range land attack projectile ammunition, it is likely that both advanced gun systems turrets will eventually be removed as the Navy fully commits to the hypersonic missile conversion. The space and power freed by removing the second turret could then be repurposed for additional hypersonic launch tubes, directed energy weapons if they ever become practical, or other emerging technologies. The USS Lyndon B. Johnson, the third and final Zumwalt-class ship, is next in line for the hypersonic conversion, and may never have an advanced gun system turret installed at all. The USS Michael Mansour will follow last. For the Zumwalt class, the integration of the intermediate-range conventional prompt strike missile represents more than a weapons upgrade. It is a lifeline. What began as an ambitious but ill-timed vision of stealthy naval gunfire support is now being retooled into a strategic strike platform, able to contribute meaningfully to a high-end Pacific fight. These hypersonic weapons provide the Zumwalt with a new mission profile, finally aligning the ship's modern design with the realities of great power naval competition. The Zumwalt's stealth capabilities give it a significant strategic advantage in penetrating contested anti-access area denial environments. Regions fortified with large numbers of sensors, radar stations, anti-ship ballistic missile batteries, and layered defenses designed to keep adversaries at bay. Unlike the non-stealthy and more radar-visible surface combatants like the Arleigh-Burke class, the Zumwalt's low radar cross-section and tumble-home design reduce the likelihood of early detection by enemy radar systems. The stealth allows it to approach closer to hostile coastlines or contested waters without alerting the defenders, providing a safer platform from which to launch its hypersonic missiles at long range. In practical terms, this means the Zumwalt can covertly position itself within striking distance of high-value, heavily defended targets, such as enemy airfields and missile launchers. By contrast, non-stealthy platforms must rely on standoff ranges far beyond defended zones or risk exposure to enemy targeting. The combination of stealth and hypersonic missile thus transforms the Zumwalt into a potent scalpel. The Zumwalt was originally designed for a strategic environment defined by uncontested US naval hegemony and a focus on littoral conflicts and land bombardments against low-tech adversaries. However, the rise of peer naval powers, most notably China, which now fields a powerful, large, and increasingly capable navy equipped with advanced anti-access area denial capabilities, has made that original configuration increasingly obsolete in the context of modern high-end naval warfare. In response, the US Navy has found a compelling new role for the Zumwalt, a stealthy, survivable platform to launch hypersonic missiles. To achieve this, the Navy is undertaking major modifications, removing at least one, and likely both, of the expensive and ultimately impractical advanced gun systems in order to install large-diameter launch tubes for intermediate-range, conventional prompt strike missiles. This transformation into a hypersonic platform takes advantage of the Zumwalt's unique stealth, size, and power generation capacity in a way that aligns with today's great power naval realities. In doing so, the Zumwalt exemplifies how naval assets must adapt to shifting geopolitical landscapes and changing strategic needs. This means evolving from a niche littoral platform into a formidable asset for hypersonic warfare. In time, we'll see whether this vision will actually be realized.